Okay, thank you.
Yeah. Okay. Well, you know, sysdynamics is not very difficult. First of all, it's just not that difficult, but it just seems difficult the way people teach it. So the way I teach it, I try to teach it to make it seem very simple. And so once you understand how system dynamics works, you can do it in any language you want.
Okay,
So for
all the
example,
language.
any language you can use it. Once you understand how it works, you can build it in any language you want.
Mm,
And I'll show you today how to do it in Excel.
okay.
And then I'll show you how to do it in Visual Basic for Excel next week. And then after that, we can talk about Python and how to do it in Python, because basically you can do it in any language you want. I use Fortran, I use Visual Basic, I use Excel, and
Okay.
but I do find a VenSim easy to work with. So
Okay.
because it's got a visual interface, I find it very easy to build models in VenSim. And then I convert the models to other languages. And then I check the model to make sure it's the same in the other language as it is in VenSim, just to make sure that I've done the proper conversion. I've converted it properly. And then after I've converted it properly, then I can go and use the language rather than VenSim.
Okay, but then the idea is convert to the other language after us building in Benzene because this is the better interface.
Yeah, it's
Okay.
you can picture the stock and flows
Okay.
in VenSim, whereas you don't have pictures of the stock and flows in Python or in Visual Basic or in Excel.
Mm,
You have to imagine what those stocks and flows are. And so having a picture of the stock and flow can be very useful to understand how to program it.
okay. Okay, thank you. I don't know this information.
Yeah,
Okay.
okay. Let me build a model in Excel for you.
Okay, thank you.
Okay, so I'm just going to build a simple model because it's the same, no matter how complicated the model, it's the same, it's exactly the same. So this is going to be a simple model of a population. And the population will have a certain number of births. And so the population is the stock of people. And then we have an inflow of births and an outflow of deaths. And like I said, I keep the stocks as a first letter capital and the endogenous variables or the calculated variables as small letters. And then I have some constants. So the first constant I will have, and I put the constants in all capital letters. And I find this very useful when I convert the program from VenSim to another language.
And the article that you sent before say this, the use of capital letters and how do you say minúscula? No capital letter for
Yeah, small
flow,
letters.
small letter. In this case, a capital for the flow. This, okay, is the rule.
It's just a nice way to define the variables so you can see them quickly and understand which kind of variables are which. So I'm going to okay, so let's so I have an initial population, I have a birth rate, and I have a life expectancy. And then I connect the variables so that I can okay, so now I have a model and I'm going to put in the equations. So I'm not, I'm gonna, I'll put in the equations. So the first thing I'll put in is the initial population, and I'll make this 1,000 people. And then I will put in the birth rate, and I will put in 0.2. And this is going to be in people per year. So this is the number of people born for every 100 people. So 2 people for every 100 people are born per year. And let me just go to the model. I'm going to change the settings here. See, it starts off as month. I'm going to change this to years. And so that's going to be years. And then I'm going to have a life expectancy, and I'm going to make the life expectancy 72 years. And then I'm going to say the initial population is just the initial population, and that is people. And then the births is the population times the birth rate, and that's going to be in people per year. And then the deaths is the population divided by the life expectancy, and that's going to be people per year. Okay, so now we can check the units. And we have the model is okay. That means the units are good, the calculations are good. And now I can run the model. And I can see the population. It goes like that. So now I'm going to take this model and I'm going to convert it to Excel. So I have Excel here. So I'm going to save this. I'm going to save this as population. Okay, so now I'm going to put the first column in. Now, every variable in system dynamics, every endogenous variable is is a column in Excel. So if I go here and I go to births, so let's I'm going to take this. Actually, I'm going to go here. I'm going to take the births and I'm going to make this a column in I'm going to make this. So I'm going to just, for the sake of information, I'm going to put the units here. So I have births and I have population. So the population is also a column. And I have units of people. And I have deaths. And I have units of people per year. Okay, and now I'm going to put in the parameters. And these are the constants. So I'll just call them constants. And let me just do a few things to tidy this up a little bit. Okay, and then I have the value of the constant, and I have the units of the constant. Okay, and the first constant I have in the model is initial population. So I have initial population. And I have a value of 1,000. And I have the units of people. And I'll just format this. Okay, and now I'm going to get another variable, or constant, I mean. So now we have the birth rate. So we have the birth rate. And the birth rate is 0.02. And we have, this is in people per year. And then the last thing we have is the life expectancy. And we have life expectancy 72. And we have units of year. Okay, and now we're going to start at 0 years. Let's actually put in the year. I have two other things I want to put in. I want to have the start year. And I want to have this time step. And I'm going to say that the start year is 0, and that's going to be year. And the time step is 1, and that's going to be year. Okay, so now I'm going to say that the start time is equal to 0. And the population is equal to 1,000. And the births is equal to the population times the birth rate. And I'm going to put a $sign here to anchor this variable so that it's going to be the same when I copy and paste it down. And then the deaths is equal to the population divided by the life expectancy. And I can just go back and just make sure that this is the formula. I should go back here and say, okay, the population here is the initial population. And you see I've put that in there, the initial population. And then if you look at the formula for the births, the formula for the births is the population times the birth rate, which is what I put in here. Population C2 times the birth rate G, G3 with a $sign. And then I look at the formula for the deaths, and that's equal to the population divided by the life expectancy. And if you see here, I've put in C2 minus G4, and I have to put in now a $sign between the G and the 4 to anchor that down. And then
the same equations or formulas. Okay.
Yeah, so this is the formulas. And then the population in, then I'm going to look at time at the next year. So I have the year here plus the time step. And I'm going to put a $sign between this and this. So now we have year 1. And the population at year 1 is equal to the population at year 0 plus the time step times bracket the births minus the deaths. And then I can put I have to put a $sign here. And now I have a new population in year 1. And then I can copy this value to get the new births in year 1. And I can copy this variable and get the new deaths in year 1. So now I have the new deaths. So now then I have the 3 formulas, and I can copy all of these formulas down here. So let's copy it down to here. Okay, so now I have, well, let's do another year.
Can you please let me see the formula of population in second time step when the year is 1? This, okay, D3, D3. Okay, thank you.
Yeah. And then the population, the births in year 2 is the population in year 2 times the birth rate here. And the deaths is the population in year 2 divided by the life expectancy. And then you take the old population, and you have the time step plus or times the births minus the deaths. So now let's take a look at Vensim just to make sure that we have the exact same results. Let's take a look at this, and we will look at this. So now we'll go down to 10 years, and we see after 10 years, we have 1,062 people at 0.82. And so if we look at the Vensim, we see we have 162.82. So we see that we have the same population here as in here. So it's exactly the same population. And if we go down to 20, so let's say we go down to 20, we see we have a population of 1129.58. And if we go down to 20, we have 1129.58. So we have the exact same results in Vensim as in Excel. So just one thing I want to do is I want to just show you what happens when I change the time step. So I'll change the time step here to 0.5. And now you see that we have the years going in half a year increments, and the population changing more slowly, so that in 10 years we now get to 162.91. And that's going to be slightly different than this. So if we look at this, we have 162.82, and here we have 162.91. And that is because we have a better approximation with a smaller time step. So if I now go to this settings and I change the time step, see the time step here is set to 1. And if I change the time step to 0.5 and I rerun the model, and I look at what happened there. I rerun the model and I look at the results. And I now see that I have 162.92 and that's the same as 162.92. So the smaller the time step, the more accurate your integration is. This is called Euler integration. So if I go here to the model and I go to settings, you can see that the integration technique is called Euler. And there's two types of integration. There's Runge-Kutta for auto and Euler, but this is just for Euler. And every program that I use uses Euler integration, and it's a reasonable way to approximate integration, numerical integration. And if you just want a more accurate result, you reduce the time step. Okay. So that's all there is to system dynamics, is basically you have a stock and you have a flow in and a flow out. And you say that the value of the stock when you start is the initial value. And then you calculate the flow in at time 0 and the flow out at time 0. And then we have a new value after a time step, which is based on the old value plus the time step times the inflow minus the outflow. And that's all there is to system dynamics. You just take the stock and the previous stock from the previous time step, and then you add the time step times the inflow minus the outflow. And that's the new time, that's the new value of the stock. And then you calculate the new value of the inflow and the new value of the outflow. And then you calculate the new value of the stock based on the old value of the outflow and the inflow, calculate the new value of the inflow and the new value of the outflow, calculate the new value of the stock based on the inflow and the outflow. So that's all there is to system dynamics. It's not, that's not magic. That's just simple arithmetic.
Simple for doing this model, but I hope in the future it's simple for me to okay, I tell you this, and it's possible do the graphic in the Excel or only of this way work
I'm having trouble hearing you. Can you raise your microphone up? I'm having trouble hearing you. I'm having trouble hearing you. Could you raise your microphone up so I could hear you better?
Okay.
Yeah, okay.
Now it's better?
Better.
Okay.
Now it's better, yeah.
Yeah, okay, thank you. That I was say that for the moment now is simple for you, but I hope in the future be simple for me too.
Yeah.
I review this information. Thank you so much. I have a question. Is possible to do the graphic in Excel or only show the system dynamic this way in the in the sheet?
Well, I'm not sure what you mean, but basically you just have to, you can produce a
Then it's
graphic.
good?
Yeah,
Then it's good?
yeah,
Okay.
you just go like this and you get a nice graph. And if I go, I would probably want to have a larger population. So let's change this back to 1. And let's extend this down. So we will have, I'm going to Okay, so now we go 100 years and we can go population. So now we have a graph of the population. And that should be about the same as the graph of population here.
Okay, it's the same. I
Yeah,
understand. It's the
yeah,
same.
it's
Okay.
exactly the same. So did you want me to show you, I can't show you this in Python, but I can show it to you in Visual Basic.
Okay.
Okay, let's take a look at this in Visual Basic. So I'm going to go to Developer, and I'm going to insert module, and I'm going to write a sub, and I'm going to call this population. And I'm going to have a dimension of, actually, let's just take the Vensim code. So I'm going to go to Vensim, and I'm going to get the documentation. So there's the documentation, and I'm going to copy, and I'm going to put this into here. So now I have actually I'm going to actually let me try this again. So I'm going to go to Notepad, and I'm going to Okay, so I'm going to now delete. Okay. Okay, so now I'm just going to do two more things. So I have to define my variables. So I will go dim birth rate as double dim births as Okay, now I'm just going to change this around. So I'm going to say that the birth rate, I'm going to say the birth rate is equal to birth rate is equal to G3. So let's do that. So the birth rate is equal to range G3. The final time is 100, let's say. The initial population is equal to range G2. The initial time is range G4. No, G5. And the life expectancy is range G4, 5, 4. And the step time is range G6. Okay, and now I'm just gonna change the order here so we see it better. So we have G birth, we have initial population. G2, G3. Okay, so now I'm going to go do while. I'm going to have to go times time. So I'll have to go dim sim time as double. And I'm going to set sim time equals initial time. And I'm going to also have a variable called print line as integer. And I'm going to say that print line equals 0. And then I'm going to have range E1 equals VBA Okay, now I'm going to do while sim time less than equal to final time and I'm going to calculate the births and the deaths. Oh, I have to put final time up there. Okay, so final time due births. Now, what the integration step is, integration, this will be population plus time step times bracket births minus deaths. And then I will print out now. So I'm going to go range E1 offset print line 0 equals population and print line equals and I just made one mistake. I have to go here and go. I have to go print line equals 1. Okay. And now that's all there is to the program. So we define the constants and then we run a loop, which is basically run a loop while the sim time is less than, or let's say less than or equal to the final time. All we have to do is sim time update. So we go here and we go sim time equals sim time plus time step. Okay, so let's save this. And I'll save it with VBA. We have to save it as macro enabled. Okay, so now what we're going to do is we're going to put the VBA in column E. So let's do a run now. If we go to developer and we see that we have, oh, we cancel that. I'm going to Okay, let's try that again. Okay, so now if we look at the graph, we can say that we have
Is the same.
so that was a VBA calculation of the population. And so let's change the population. So I'm going to change the step time to 0.5. And now we see that we have a different result for the VB for the Excel. So let's call this Excel population. And call this VBA population. And so now we have a different result, but if we run it again, we now get the same result. And if we change this to 3,000, we now get a different result. And if we run it again, we get the same result. So we can see that we can implement a Vensim model by just taking the Vensim code here and converting it to VBA with some fooling around. And so if we look at the VBA code, we see that we have we've defined it like that.
Okay.
So
Thank you so much.
Okay, I'll let you go. You're past your time. I'll send you this spreadsheet. I'll send you the Vensim model, and you can see if you can replicate it. I'll send you the video, and you can see if you can replicate it.
Serious, thank you so much for your time and knowledge. Take care and take rest so much.
Have a good week. Bye-bye.
The same, bye.